Hi guys, we're going to talk about bond and development in today's video. Now let's look into what the term bond refers to. The term bond refers to the adhesion between concrete and steel which resists the slipping of steel bars from the concrete. This bond is responsible for transfer of stresses from steel to concrete. Hence, it provides a composite action of steel and concrete in RCC. Now, the bond between steel and concrete can be increased by using twisted or deformed bars, using a rich mix of concrete, adequate compaction, and curing of concrete for proper settle. Compaction means when you pound it and get rid of the voids of the mold. And curing of concrete means when you give it adequate moisture, that is to increase the water absorption by heating it at a particular temperature, so that it can properly settle. And then we provide hooks at the ends of the reinforcing bars. These are some of the ways that you can increase the bond. Now there are different types of bond failures that occurs, and we'll be looking into both the types of bond failures. One is anchorage failure, the second is flexural failure. Now let's look into each of it in detail. Okay, first one is anchorage failure. A tensile force acts on the steel bar. Due to the action of the tensile force, the reinforcement bar has a tendency to slip. So to resist the slipping of concrete, a bond stress is developed. Not only that, we increase the length of the steel reinforcement bar, that is known as length development, so that it can attain its full strength. We can look into development like in the later slide in this video. Now let's look into flexural bond failure. Flexural bond failure in a simple beam. Take this as a simple beam at the critical section, that is near the support, at points of inflection and at points of high shear force. Point of inflection and at points of high shear force, their high bond stresses are developed due to large variations of bending moment. These bond stresses are called flexural bond stresses. Now, as per IS code, there's a formula for development for both bond failures. We'll be using to control such failures. There is a particular formula for development and its value has to be either greater or lesser so as to prevent this failure. Now to know that, first let's check what is development length. Development length is the minimum length of bar which must be embedded or trusted to concrete so as to get its full strength. This is also known as anchorage length in case of axial tension or compression, and development length, usually we use development length in case of flexural tension or compression. The formula for development length is LD is equal to 0.87 F55 by 4 tau BD. This is how we got the development length. We take a particular beam subjected to a tensile force. The previous image a tensile force is acting on it. T, what is the when a tensile force acts on it, a stress is developed, right? So with the formula of what is the formula of stress? It's equal to force by area, right? Here we have to find the tensile force. That is stress into area. The stress developed is bond stress. That is the tau BD. That is the stress that acts at the interface of the concrete and steel, tau BD, into, when you look at the side, it looks, the cylindrical reinforcement looks like a rectangle. So the area used here will be length into breadth. Here the length is the development length LD and breadth is the circumference of the circle. That is 2 pi r, where r is equal to diameter by 2. That is 5 by 2. But we also know that T is equal to tensile force is equal to 0.87 Fy into A5, in which A5 is equal to pi by 4 into 5 square. We substitute the value and we get LD is equal to 0.87 Fy 5 by 4 to BD. Now to prevent anchorage failure, that we will look into the next session. It will be based on these anchorage and flexural failure will be, to prevent them, it will be based on this development length. Now the prevention of failure. In anchorage failure, to prevent slipping, LD value, that is the development length value, should be greater than or equal to 0.87 Fy5 by 4 to BD. In flexural failure, LD is equal less than, or LD value should be less than or equal to M by V plus L naught. Okay guys, so that's all for this video. I hope you've understood the topic that I've taken today about bond and development length, and how we can prevent the failure of the bond stress due to the bond stress that take place using the formulae of development length. Usually we'll be using LD is equal to 0.87 Fy5 by 4 to BD when we are designing a shear reinforcement, and we have to find the development length when we are designing a beam. When we're designing a beam, when we have to find the development length, we'll be using this formula. LD is equal to 0.87 Fy5 by 4 to BD. With this, I'm going to conclude. Thank you.